Hi everyone, welcome to my presentation on Interprocess Communication. I am Sharmila from the Department of Computer Science and Engineering. In this session, we'll explore how different processes in operating system communicate with each other, why IPC is important, and various IPC mechanisms. Let's get started. Very firstly, the IPC, which stands for Interprocess Communication, which allows the processes to communicate and synchronize their actions. Processes can be running on the same computer or distributed across a network. Why is interprocess communication is important means which allows data sharing between processes, enables coordination and synchronization, efficient resource utilizations. In the types of interprocess communications are shared memory, message passing, pipes, sockets, and semaphores. Very firstly, the shared memory. The shared memory definitions is a segment of memory is shared between process for data exchange. Example like communication between a parent and child process in an OS. The advantages is faster communication than the message passing. Its challenges require synchronization to avoid race conductions. Then very nextly, the message passing. Message passing definitions processes send and receive messages using a communication link. The examples like client server application, email communication system, methods of message passing are synchronous and asynchronous. Synchronous means blocking and asynchronous means non-blocking. Synchronous in which the sender waits for a response. Asynchronous means sender continues execution without any waiting. Then very nextly, the pipes. The pipes are used for unidirectional communication between related processes. Example, Linux command, which passes output as 1 is to grip. Then the types of pipes like named pipe and unnamed pipe. The named pipe used for communication between unrelated processes. Unnamed pipe used for communication between parent-child processes. Very nextly, the sockets. Sockets allow bidirectional communication between processes over a network. The client server model is an example of socket because a web browser communicates with a web server using TCP sockets. The types of sockets like stream sockets, datagram sockets. The sockets are reliable communication. Datagram sockets are UDPC, which is faster but less reliable. Very nextly, semaphores. The semaphore is used for process synchronization to prevent race conditions. Example, multiple trends accessing a shared database without conflicts. The difference between the semaphore and a mutex is the semaphore can have multiple resources access permissions. Mutex, which is the mutual exclusion, only one process can access the resource at a time. Then the IPC mechanisms are system calls, library calls, or functions, specialized hardware. The system calls, which means the system calls. The examples like pipe, socket, system kit. These are the methods of system calls. Very nextly, the library functions. Example, POSIX IPC function, system V IPC functions. Then the specialized hardware IPC. Example, Shared memory hardware, message passing hardware, which are seen previously. Then the monitor. A monitor is a high level synchronization construct that allows process to access shared resources. Example, monitors in Java. Then the important topic of operating system is deadlock. A deadlock is a situation where two or more processes are blocked indefinitely. Example, deadlock in a banking system while banking transactions. The real-time systems in interprocess communications are which is predictable, reliable in this real-time system. The real-world application of IPCR web browser using multiple processors, multiplayer gaming communication, cloud computing services. Then the benefits of IPC or inter-process communication is enables communication between processes, which improves system performance, enhances system reliability. Challenges of inter-process communications are synchronization and coordination, deadlocks and live logs, security and authentications. IPC in modern operating systems are like security risks, how to secure IPC or the modern operating systems of inter-process communication, which is very useful. The future trends of inter-process communications are AI-driven inter-process communication optimization, quantum communication or computing, and inter-process communication, 5G and low latency IPC in IoT. Welcome. In this conclusion, so that was an overview of inter-process communication. Each mechanism has its own use case depending on the scenario. Thanks for watching. If you have any questions, feel free to ask. Once again, thank you.